Hey guys, this is Mr. C with Chapter 8, Lesson 3, which is rotations. So let's just get started with it. What is a rotation? A rotation is a transformation that turns a figure. So if you're looking for that one-word definition, a rotation is a turn, and it turns it around a fixed point that's known as a center of rotation. So I put a little box around this just because the center of a rotation, generally it's going to be the origin, the middle of the graph, but it could really be any point. And we'll look at a couple examples of that. But just so you have the background information and the vocab, rotation is a turn around a fixed point. Fixed point is called center of rotation. And the number of degrees that you rotate a figure is known as the angle of rotation. So, for example, we have this weird shape, and it gives us a center of rotation. So if we rotate it one time, and everything that we do in class is going to be, and from this textbook, is going to be counterclockwise rotations. So instead of going around like a clock that way, it's going to go the opposite way. Anyways, there's an example of a 90-degree rotation, so that's one rotation. And then again, it goes, so that's 180 degrees, 270, and obviously a complete rotation around in a circle is 360 degrees. And those are generally the four main angle of rotations that we'll deal with. Okay, I'll give you a figure, ask you to rotate it either 90, 180, 270, or 360. And 360, really, you're not rotating it because it's right back to where it originally started. But that's rotation's background knowledge. So the first thing I want to look at, first of two things, is rotational symmetry and what it is. All right, so you know what a line of symmetry is. Now, rotational symmetry is a little bit different. It can be tricky if you don't know what it is, so just pay attention. If you can rotate a figure 180 degrees or less, so anything from 0 to 180 degrees, and the original figure will match the image of where you've rotated it, then that figure has rotational symmetry. So I got this picture of a sea star because it's very simple to see rotational symmetry in something like a sea star. If you look, there's 5 different points. So if I rotated this, I don't even have to rotate it 90 degrees. I can rotate it just to here. And essentially what happened? Let's look. This arm or leg or whatever it's called of the sea star is moving here. This one is moving here. This one is moving here, and so on and so forth. So really, I'm rotating this sea star 1/5 of the way around because there's 5 arms of it. So if I rotate it just 1/5 of the way around, I'm going to find that it looks exactly like the original. Of course, all of the arms on a sea star aren't perfectly the same, but the general shape it stays the same. It ends up in the exact same positions. Arm here, arm here, arm here, arm here, arm here. They're just different arms because, of course, we rotated it. So a sea star is a great example of a figure that has rotational symmetry because we can rotate it less than 180 degrees and the image matches the original figure exactly. Now, a question I could ask you, and I will ask you, is, so we determined that sea star rotated 1/5 of the way around. So to determine the angle of rotation, a full rotation around is 360 degrees. Well, you need to ask yourself, what is 1/5 of 360? And that will be your angle of rotation. So 360 times 1/5. And if you use a calculator, just do paper, pencil math, whatever, you should get 72. So for something that rotates 1/5 of the way around, that's a 72-degree rotation. So what is the angle of rotation of this C star if I rotate it so that this point moves here, that point moves there, that moves there, and so on and so forth. The angle of rotation is 72 degrees. And that's how you find any angle of rotation. You take what is a full rotation, it's always 360, and you multiply it by how many times you rotated it as a fraction. So this has 5 points. I rotated it 1/5 of the way around. 360 times 1/5, 72 degrees. Basically, I found what is 1/5 of 360, and that's 72. All right, so let's look at a quick example of that before we do some actual rotations of figures on a graph. Technical difficulty. Okay, so here's an example. Does this weird looking star circular figure have rotational symmetry? If it does, then find the angle of rotation. So it's actually easier than it looks to find out if this has rotational symmetry. Remember, rotational symmetry means I only have to rotate it 180 degrees or less and get it looking exactly like it originally did. So here's how it originally is. If I rotate this so that this point here moves here, and this moves here, and so on and so forth, then this will be here, this will be here, this will be here, this will be here. So if I just slightly rotate this to the left, then it ends up looking exactly like the original, which means it does have rotational symmetry because, let's just double check, 360 degrees are in a full rotation. I'm doing, just like the C star, a 1/5 rotation, right? I'm moving this to here, and there's 5 places that it could move to get back to the original. 1, 2, 3, 4, 5. And that is 72 degrees. 72 degrees is less than 180 degrees. That means that this figure has rotational symmetry, and with a 72-degree angle of rotation. All right, there's not much more to that. We'll do some examples hopefully in class. If you have questions, I can clean it up a little bit for you, but that is rotational symmetry and finding the angle of rotation. Now, for all the rotations that we do in here, you're going to be given the angle of rotation. So here's an example. And like I said, for this chapter, you're going to need graph paper. All right, this says, graph the image of triangle ABC after a rotation of 90 degrees around the origin. Then name the coordinates of the image. So here are the original coordinates. A is at 3, 3, B is at 1, -1, C is at 3, -3, and I've already graphed that out for you. So there's your original triangle. Now, to do a rotation, like I already said, first off, everything that we do in here is going to be a counterclockwise rotation. Just to keep it simple, I'm not going to mix it up and say some are clockwise, some are counterclockwise. So everything we're doing is counterclockwise. So that means it's going to move in this direction, okay? Because the clock usually moves this way, we're going to move counterclockwise. 90 degrees. All right, the easiest way to explain to do a rotation, and I will do these in class with you so that you can see on actual piece of graph paper, but you're literally going to physically rotate your piece of graph paper. And it's a little difficult for me to show in a video, but hopefully I do a good job. So I'm going to actually take my piece of graph paper, which mine is, I know, on a computer, and I'm going to rotate it 90 degrees. So it went from up here to 90 degrees counterclockwise. All right. And now you're going to notice that A, B, and C are in new locations. It's like we have a new X and a new Y axis. Now, that's just for now. We're going to turn our papers back in a second. But while your paper is turned 90 degrees counterclockwise, you're going to record each of the new points as A prime, B prime, and C prime. So now A is over here. So now it's at 1, 2, 3, -3, 3. All right? And B is now at 1, 1. So we're going to call that B prime. And then C is now at 1, 2, 1, 2, 3, 2, 3. All right, and we're going to call that C prime. Now, You take your graph paper and you rotate it right back to where it originally was. And now you take your points, A prime, B prime, and C prime, and graph them. 1, 2, 3, 1, 2, 3. So it's negative 3, 3 is A prime. B prime is now at 1, 1. And C prime is now at 1, 2, 1, 2, 3, 2, 3. C prime, and now connect them. And now you have triangle ABC rotated 90 degrees counterclockwise to get triangle A prime, B prime, C prime. All right, and I've named the new coordinates of the image just like the directions asked me to do. And that's all there is to a rotation. These are definitely the most difficult transformation we've done so far, and it takes a little bit of practice, and honestly, some of you might need to physically see me do one in class on your piece of graph paper, but again, the steps are you plot your original points, make your triangle, look at the angle of rotation, and here it's 90 degrees. Physically turn your paper 90 degrees, or whatever the angle of rotation is, and then look at where the original triangle now is, mark those coordinates down, turn your paper back to the original, and then plot the points, and you've got a rotation. So let's see that again with a different example that might help some people. JKL, I've graphed it. If you think that you want to try by yourself, pause the video and plot these points and then follow the instructions. This is going to be two different rotations, one that is 180 degrees and one that is 270 degrees. All right, so we know that we're going to have A prime, B prime, and C prime. That's after the 180 degree rotation. And then we're going to have a double prime, B double prime, and C double prime. And that's going to be after a 270 degree rotation. So let's give it a shot. After you've graphed this, take your graph paper and actually turn it 180 degrees to start. So one turn to the left, that's 90. Another turn to the left, that's 180. So now let's look at where our points are. J is now at 1, 2, negative 1. B, oh, I should have called these JKL, excuse me. J, K, L, J, K, L. I got caught up with my ABCs, sorry. So K is now at 1, 2, 3, 4, 5. 1, 2, 5. Negative 2. And L is at 1, 2, 3, 4, 5, 6, 1. All right. Again, it's kind of like you have a brand new X and Y axis, and you just pretend that this is the X and this is the Y and find your coordinates. And now we were also asked to do a 270 degree rotation. Well, we've already gone 180 degrees, right? So we only need to do one more turn to get it at 270, right? Because 90, 180, 270. So now we're at 270. All right, so let's look at where our points are and record those as coordinates. So J double prime is at 1, 2. K double prime is at 2, 5. And L double prime is at negative 1, 1, 2, 3, 4, 5, 6. Negative 1, 6. All right, and the last step is the easiest as long as you're okay with graphing things. All right, let me just slide this over. Turn it back to how the graph originally was. Right, that's your original figure. And just plot some points. So J prime is at 2, negative 1. J prime. K prime is at 1, 2, 3, 4, 5, negative 2. Okay. And L prime is at 6, 1. Pretty cool. There is your original, and that's where it would be after a 180-degree rotation. And then lastly, let's mark J double prime at 1, 2. So J double prime. K double prime at 1, 2, 1, 2, 3, 4, 5. K double prime. And L double prime at -1, 6. All right, connect those up. And this right here is a rotation of 270 degrees from this guy. So from here to here is 180 degrees, and from here to here is 270 degrees. And that's all there is to rotations. Maybe I make it sound like it's easier and actually a little difficult for you. No worries, you'll be good after a little bit of practice or a lot of bit of practice. So that's what we'll be doing in class the next day or two. But for now, that's the lesson. So here are your summary questions. There's 3 of them. And I'll make the screen big again. Move this. Okay, so give them a try, write them down, give your best answer. I'll check them in class. We'll go over everything. If you have any questions, send an email or write it down to remind to ask me in class. But there's question 1 and question 2. And here is question 3. You can probably all have them on the same screen. There you go. Do the last one obviously on graph paper, and you're going to be rotating a rectangle instead of a triangle, but it's the same exact steps. So if you need to see the video again, rewind, watch what you need to, and I will see you in class. Do your best, and that's rotations.